I thought I'd try and pose a couple of questions, actually, just to do with thinking about why we can reuse things, how we can reuse buildings, whether we should be doing that, and what factors are kind of leading to that. So I suppose what I was hoping to try and do was to actually, first of all, unpick some very, very basic things that we're all kind of familiar with in our everyday life, and actually need to sort of look at those to actually ask the question, why is it that these things get recycled? And maybe from taking those things, maybe try and understand how could those lessons maybe relate to maybe more like a built environment. How could that relate to maybe how we look at, let's say, a plant system, or how could that maybe relate to actually how we think about designing that system in the first place, right through to the point where we're actually maybe looking at a couple of buildings. And at the end of it, I'm going to try and give two case studies which have very extreme different examples of reuse. One which actually takes not much of a regard for actually anything happening with the end of life, and there's a few reasons why I think that's probably quite good. And another one is actually all about saying, well, actually, let's try and do the maximum that we possibly can to investigate reuse in that process. So I think that's kind of what I'm going to try and do, and I think we've got sort of 10 minutes, haven't we, for me to, quarter of an hour for me to try and do that. So I'll try and be quick. So I just quite like the sort of idea here, you know, the sort of the Pepsi kind of van, you know, and how we approach kind of what is a piece of product. So just to give you a bit about my background, I'm an economist, so I think, forgive me, there might be a couple of graphs that I'll chuck into this, but the point which I was sort of try and do is to kind of take an economic angle in understanding why we perhaps reuse things or don't, and then linking that back to kind of carbon. So, you know, what decides? And I think essentially we don't do really anything without having a benefit behind it. We might be a certain amount of altruism in all our design principles, but there has to be some sort of benefit in that. And I think that's quite an important thing actually to have inside it. And I think typically with things like reuse, the benefits tend to happen way in the future. They don't happen in the moment. They happen a long way off. So how does that kind of factor into the equation? Well, I think what is also the cost of actually going about that. So we've got a nice piece of cake, but what is the damage the bad piece of cake or good piece of cake does? So what's the relationship between those two things? And I think that's a sort of a second quite important idea. You know, I think you maybe take something, let's say, like a London stock brick. It's actually quite costly, quite time-consuming, and a real nuisance to try and clean one of those up. And yet the fact is there's a lot of value inside that material, so it actually becomes worthwhile for people to do it. And I think the third element in this equation is time. And I believe we can solve, or at least use these three tools to understand whether we should be reusing, if we want to try and encourage it, how we can actually incentivize that so that designers and people in the future can actually take account of it, and to actually find a few different sort of solutions to it. So I think time, you know, benefit, and cost. And I think those are the three ideas I just want to sort of drop just now. So reuse, I think that's quite like that sort of image. So here's an example of something that we're all probably quite familiar with. It has to probably be the epitome of something which has a short lifespan. The average life expectancy of a metro is probably around about 6 hours. I've sort of done a bit of supply chain analysis, working out how long it takes to be shipped across sort of London and the length of time until it gets discarded actually on the tube train. I've calculated also some residual benefits and residual costs. You know, the value of the paper and the value of actually, or the cost of actually extracting that value. So, you know, essentially, you know, the value of the resource, the paper pulp inside one metro is worth just over a penny. And the cost of actually picking up those metros and getting them from actually a dense urban environment, let's say like all the tube stations, is just under a penny. So it stacks up. You know, I think that's the first big tick in the box. And I think the third one actually is, let's look at the carbon associated with that. You know, it takes about 0.3 kilograms of CO2 associated with this package of newspapers. So that's the kind of other side attached to it. And the residual cost of that supply chain to pick them up from the distribution centres is about a sixth of that. So it really makes a lot of sense from an environmental perspective. I think that's an interesting idea as well, because sometimes things can actually make financial sense which don't make environmental, and I think there might be quite a few interesting illustrations of that maybe on an M&E scale when we look at things like wind turbines which are kind of being built in the North Sea, which actually are amazing pieces of engineering and infrastructure and are sustained by pretty generous sort of subsidies at the moment, but how do they stack up from an environmental perspective when we take account of the embodied energy, the embodied carbon it takes to make and maintain these particular installations? And did we really think about that at the time when we were saying that this array is a great idea? So, you know, I think those relationships are quite important. I talked about the brick, and I think this is another one actually where the cost of actually trying to clean one of those, I spoke to a couple of contractors a few days ago to try and get those sort of figures. It's about 35 pence per brick. But it can be quite varied. So here it's quite interesting where the sort of choices of specifiers that we make can have quite an impact. So if you've got a lime mortar going on in your building, that's going to make it quite easy to pull those bricks apart and actually to clean them after end of life. Whereas if it's cement, it's going to be an absolute nightmare. So there are decisions that we make today which have repercussions in the future. So maybe it's worth thinking about that as well in terms of when we're specifying materials and products and when we design buildings. I think the key with this is actually that the economics make a hell of a lot of sense now. So even though it's a long time ago that these bricks were first cast, today it actually makes sense. So that's why it's still done. This is probably quite an extreme one, and I think I thought I'd put this out there as well, because we have to take account that something that we can't really predict, and that's fashion. You know, who would have thought that this chair, when it was first made, that around about 30 years later, it'd be worth around about 3 times what it was when it was first made. This is on eBay at the moment, so it's a £620 second-hand chair. You know, you can get a chair much cheaper than that kind of made. And I think the carbon story is actually quite strong here as well. But a lot of what may determine actually how we think about buildings actually can be in the same way. You know, if we look at things like raised access floors that we had in the 80s when you sort of go around to Broadgate and you can even sort of crawl around inside them because they're about half a metre kind of thick. But today we're putting very slimline solutions in, and we're using the wireless a lot more to kind of transmit and kind of more a mobile data network. So fashion is something that we can't predict, and that can actually throw all these sorts of ideas that we might be saying about trying to incentivize end-of-life impacts in the bin so we can best one in the world. I suppose what I'll do is I'll throw a caveat to that, which is that, you know, when someone asks me what I think is a really good building in terms of embodied carbon, I'll throw out maybe something, let's say, like maybe I'll throw out something like the Empire State Building. I think that's great, actually, because, you know, if you look around it in the skyline of New York, you've got a whole series of curtain-walled buildings which, you know, they're going to be there for perhaps another, like, 15 years, and you know they're going to be pulled down. But even though the Empire State was a building which took an enormous amount of carbon to make it, it's all made out of individual bricks, but just quite cleverly put together. It's something which is really iconic, and I think this is where maybe an idea of quality might be something we're thinking about as well, that quality lasts, and that can be thrown into the equation. These are 2 quite contentious ones, and I'll put them together, and it's to do with looking at things like anodizing and aluminium. And I think this is an interesting one, actually, because you can recycle a lot of things. So you could recycle the aluminium that's coming out of this table here, but is recycling always necessarily a good thing? And I think some of you might kind of know this, but actually, that when you try and recycle something that's been anodized, you can't turn it back into aluminium sections. It's just not possible. And the way the industry is set up doesn't actually allow that. What happens is when you recycle an anodized section, it gets turned into road fill. It gets ground up and gets chucked into road fill. And that's using an enormous amount of carbon. You'd be better off just using, you know, builder's waste or sand than actually kind of using something which is really high energy to try and do that. Whereas if you use powder-coated materials, that's something actually which is quite easy. You can put it straight back in the pot, and you can be extruding new sections out of it afterwards. So maybe that's sort of an idea when we're thinking about maybe the finishes that we want to be using. And everyone likes that nice quality anodized finish, but does it need to have to be all over the item? Could we, for instance, just put it on the end of the profiles on the outside of the buildings? Do the back frames, which actually hold the curtain wall in place, have to be anodized? And there's a lot of money that goes into that as well. So, you know, is that something that's really worthwhile doing? So, you know, that's another sort of thought about maybe things that we can choose today when we're designing something which actually allows the possibility of valuable reuse at the end of its life. So I think, you know, that's kind of what I was just describing here, really, which is that, you know, that there's no residual financial benefit associated with anodized aluminium. It's just something that, you know, when I specify, it's kind of right in our specs saying, please recycle the aluminium. It's really important to do on site. We're actually going to be causing a financial as well as an embodied carbon burden out of that supply chain as a result. So that's just kind of putting it. Whereas if you compare it to, let's say, the residual benefits which come about from actually powder coating it, is actually a really compelling argument to be doing something like that. So, life expectancy. So I think there's a couple of ideas I've sort of put there, which is about the benefits, the choices that we make today. But what about life expectancy? And as I said, I was an economist, so I'm afraid there's going to be a couple of graphs coming up now. But I think they're quite interesting ones because they help us think about actually the value of money over time and the value of environmental damages over time. And this is probably quite this is a big problem, actually. We're trying to make any of these things stack up. Because every year goes forwards in the future, £1 is worth less than the next. You discount. In a cash flow which goes over a number of periods, something which actually is coming from further in the future is less than the £1 that you have in your pocket today. And the crucial problem with all of this is that the rate that the £1 goes down in value, as you could say, or the compensation for the delay, it goes in a straight line, so it goes down every bit. So if you're trying to make something stack up, or to try and make a compelling financial argument for some kind of end of life or end of reuse happening a long way in the future, there's not going to be, how can you try and persuade someone that there's a value in that today if it's a long way off? And I think I'm going to contrast that with actually maybe something, let's say, like the impact of carbon emissions. And I'm going to tell a little bit about that in the sort of context of sort of environmental economics, because the value of carbon emissions, the damage it has in the atmosphere, it's relative to a whole pile of things going on. It's relative to the amount of carbon that we have up in the atmosphere at any given moment in time. It's relative to actually the technology, and it's not linear. So you actually have like an inbuilt problem with trying to make environmental impact stack up. So I think if I can drop any kind of bomb today, is to say, take the economic ones seriously, because they can actually help incentivize change more strongly than the values associated with the carbon itself, even though it's a really, really important thing. And I think this is quite interesting as well, because when we look across building types, time is all very different, in terms of lifespans. And I think that this is actually a picture of a building that I've been involved with actually recently, which we've actually wholeheartedly moved the building just down the road. The whole thing has just been transported. But you've got very short life buildings down at this end of the spectrum. And I think there was a report which came out about 6 months ago, which was looking at non-listed buildings in the City of London. They found that the average life expectancy was 17 years. I think that fact, I find really disturbing, the thought that actually an office that we're building and putting all this energy and all this carbon into. And actually, if you think about our efforts as designers of systems, we're putting all this investment in stuff, the lighting, the plants and things, and actually it's only going to be there for that short length of time. And yet there's other things right down the other end of the spectrum, which might be schools, retail, maybe more traditional buildings like houses, and not so prime locations such as the City of London for offices, where you might have a building that lasts over 250 years. And I think when you look across London, you can see that sort of variety. And I think maybe when we're thinking about the choices about how and what we want to incentivize, that's something quite worth having in mind. So we go on here. So I'll throw one idea with that, which is actually the push for deconstruction on short life and push for quality and durability when you've got something that's to last longer. See if I can flick on. So I'm going to give you two quick case studies, and then I think I've got, that's my time, isn't it? So a short life example, and I think this is that office, the warehouse building I was telling you about earlier. And I think what's really interesting about this is it comes about from the environment where you could call it fashion, but it's actually about changes in logistics. And logistics changes, it evolves really, really fast as a sort of sector. So this building was only actually got about 15 years old. And then all of a sudden, all these big trucks which are moving food around actually the country in Slough from the distribution centre for this particular client, they just didn't fit in this shed anymore. So the shed stopped being useful as the changes with the infrastructure changes. So how do you go about designing a new building, taking that account of that? And I think what we've done here is we've actually dismantled all of this building and reincorporated it in a new one just a couple of miles down the road. And I think what's quite interesting here that this process has actually saved them money in, of course, doing it by about 4.5%, and it's reduced the carbon footprint of this particular scheme by around about 40%. And when I talk about carbon footprint, I'm talking about the embodied and the operational. And that equates to around about 500 tonnes of carbon saved, equivalent to a hectare of rainforest, thinking in those sorts of terms. And then the final example, which actually is something like WWF, which is a project that we've been involved with as well. And I think what's interesting about this one actually is it's not really designed much for disassembly. It's the offices and owner offices, occupiers office occupier office, which actually is, they're going to plan to be there for around about 150 years. That's the sort of design brief of the building. It's not in London, so we're not really expecting any sort of weird pressures on the value of the land in this particular location. So really, all in this case, it's about durability and trying to make the building last and perform as best as possible. And I think in this case, the carbon footprint reduced on that was about 42%. But it's actually focusing all on the supply chain side of actually what you're bringing into that building and the energy it takes to make those components in the first place. I think this was quite interesting because I've touched before about the relationships between the operational and the embodied, and I think, you know, on this building we've sort of found that we actually had a really nice offer actually from some particular glazing company to have free triple glazing, and like how many clients would love the thought of being offered free triple glazing. But actually we sort of found that the additional carbon it took to make that third pane, the structure, the gasketry, and all the sort of elements that went associated with that system, that the embodied carbon associated with doing that was actually greater than the operational saving it would deliver across the end of life. So actually in that instance we pulled back to something that was just double glazed. And I think in this case there was no impact on costs. And I think that's probably my time slot done. Just looking at the relationship between the operational over 60 years. So there's the yellow sections here are the operational emissions associated with the building over 60 years, and this is the embodied impacts from the design, which relate to the energy and carbon from making and maintaining the building. So I think the three bits I was going to sort of throw out was, you know, how can we maximise the residual benefits? You know, thinking about the sort of the cost and the benefit of undertaking some sort of process to salvage the environmental value and financial value from something. So think about those residual benefits is my sort of first thought. I think that the next one actually is minimise the residual costs. You know, how can we think about putting together systems so that they're more modular, using bolts over things like welded construction? I think finally, you know, if we're looking at the type of building that we're creating, how can we try and design that with respect to time? You know, if we think short life, how can we think about disassembly? If we're thinking about long life, how can we think about quality? I think that's my bit. Okay. Thank you very much.